My pleasure to introduce Dr. Ryan Darcy, the president and CSO of Health Tech Connects and co-developer of NeuroCatch platform. He also holds professorships in Neurotechnology at Simon Fraser University and University of British Columbia. He has over 300 scientific publications and over 100 million in funded research. Today, he'll be sharing some before and after NeuroCatch traces, showing faster latencies.
In medicine, there's this well-standing axiom that you can't treat what you can't measure. When we think about vital signs, we think about how we care for cardiac function through something like blood pressure. We haven't actually worked towards getting a vital sign for our cognitive brain health. Immediately, you can see that his cognitive processing, when you did the 10-minute glow sequence, his cognitive processing sped up dramatically to 314 milliseconds. This was one of the most impactful differences where we were like, wow, this is a performance advantage around cognitive anticipation.
Welcome, everyone. Thank you all for being here. Now, it is my pleasure to introduce our guest speaker, Dr. Ryan Darcy.
Thank you for having me, Brooke. Well, thanks everyone for tuning in. And thanks for the lovely introduction, Brooke. My background is in specifically neuroimaging and neurotechnology. And I've spent my career working with some of the most advanced neuroimaging and neurotechnology platforms in hospitals, translating that into neurology and neurosurgery. And it's a pleasure. One of the things that's always driven me has been to really get it out of restrictive hospital settings and get into the real world. And it's kind of a pleasure to get to do this presentation because that's really one of the key things that we're going to be talking about today. Just by way of disclosure, I did co-found Health Tech Connects, which actually is a company that oversees 3 separate companies. We'll talk lots today about the NeuroCatch platform, which is our portable brain scanner. But our measurement system with NeuroCatch created actually a clinical trial center called the Center for Neurology Studies, where we first encountered Neuronic actually in terms of pulling in really incredible interventions and doing evidence-based science on them to validate them, not just with NeuroCatch, but with a number of different measures. When we do that, we're starting to really identify effective treatments and interventions. And so we actually do also operate a physical therapy and performance clinic called NeuroPeak in the Vancouver area, which allows us to sort of roll these things right into the front lines of clinical practice. So just to set the stage, today, I think the central theme that I really want to drive home is in medicine, there's this well-standing axiom that you can't treat what you can't measure. And the measurement problem in neurology and neuroscience is particularly acute in the sense that a lot of our measurements, I'm trained, of course, in clinical neuropsych, so I'm not saying that our measurement system hasn't provided us with a tremendous amount of value over the evolution of neurosciences. It just has largely been subjective and error prone. We primarily focus historically on behavioral measures, which what we've started to do is really move to more objective measures that you can get, as you'll see in the talk today, from neurophysiology and EEG. And the overall framework that we've looked at over many, many, many years now is, can we take all the complex neuroimaging and actually go and do the opposite, simplify it into something as simple as a vital sign. In fact, we've asked ourselves the questions that why is it that when we think about vital signs and we think about how we care for cardiac function through something like blood pressure, we haven't actually worked towards getting a vital sign for our cognitive brain health. And so that's been the primary thrust. And for today's talk, I'm going to kind of balance. I'll talk about some science of NeuroCatch, but I'm really going to talk about some kind of in-field clinical applications of NeuroCatch with Neuronic. But ahead of that, so that it's really, I think, setting the stage to understand what we're seeing with NeuroCatch, I'm going to take you some time to take you through kind of what NeuroCatch is and what the science is. So if we dive a little bit into the concept of brain vital signs, this is just one slide to get you oriented a little bit. We started doing this work back in the sort of mid-1990s and really tackling the concept that you needed an objective measure of how someone's cognitive brain function was. We've used a number of different brain imaging technologies over the years. One of the key things that has really put electroencephalography or EEG front and center is that it has increasingly met the needs of outside of a demanding, difficult to access neuroimaging lab. So it's lower cost and portable. And from it, you can actually derive from the brainwave activity, you can actually extract specific signals for processing stimuli, sensory, cognitive, and attentional stimuli. And this is in reference to the literature on what we call evoked potentials or event-related potentials, or ERPs. And so what we do there is we actually, you'll see in a minute, put non-invasive sensors on your head. We then actually can ping your brain system through stimuli. You can do this through auditory or visual or even somatosensory and other forms. We primarily use auditory, and we use a combination of tones, beeps, and then basic words. And in the upper right-hand corner of this slide, you can see that what we started to focus on as well, this event-related potentials have been done throughout labs across the planet. We decided what we wanted was to extract the top 3 responses that tell us about our brain as we're processing information from low-level sensation, that would be the N100, to higher level basic attention, so attentional processes of unexpected loud tones, for example, if you're hearing a train of tones. And then even higher level, if we give you, words that, for example, today, Thursday, are matching words, and then we might violate that with something like today, Monday, which would be a mismatch for hopefully all of us, not one we want to pair with. So those stimuli elicit these 3 key responses for sensation, attention, and cognition, the N100, the P300, and the N400. And I'm going to teach you about these 3 responses, but we're going to really focus specifically on this cognitive processing N400 response. So the trick with NeuroCatch and driving the brain vital sign science and literature was actually not to invent brain signals, but it was to get it out of complex laboratories, utilize objective neurophysiological responses, make it deployable to the point of care, make it so that it wasn't expert dependent. So it was automated. So whether or not I do the exam or anyone does the exam, it's the same result. That, of course, allows it to be standardized so we can have norms. And we wanted to take this complex brainwave data and create intuitive results. And more specifically, we couldn't afford to spend hours in a lab. So we needed to make this rapid. And NeuroCatch runs in basically 5 to 10 minutes. It's actually 6 minutes. And it runs on an economical platform. So what you can see is this is actually what it looks like. And it actually marries really well with neurons. So what we've been able to do, we put a cap on an individual's head, and you can see in the middle of that cap are the sensors that are the recording brainwaves. And you can actually keep that cap on and put the neuronic over top and run them, I'll show you in a minute, either before and after a neuronic, or even now there's intrepid individuals out there who've run them at the same time. The results, well, first of all, the technology you can see in the upper left-hand corner, it's very portable. In fact, we don't even send it with this case anymore. It goes in a backpack or a little carrying case. It's a laptop, and basically the hardware is a very, very small, a little larger than a cell phone for recording from this cap. And you'll see in the center of this image, the principal result, we plot all these 3 responses on a radar plot, and I'll take you through that so that you get familiar with that. Just ahead of that, I want to drive home the point that it's really important that what we are looking at here are objective measures, objective evaluations. So this is not a subjective measure as to whether or not you feel that neuronic is working or not. It is actually measuring brainwave changes to determine whether or not it is. And as I've mentioned, we're extracting those from ERPs, and you can see here that if you were to take the term event-related potential and put it into PubMed, you'd actually find that all the way dating back to sort of the 1930s, late 1930s, there's over 65,000 peer-reviewed articles on this. So this neurophysiological measure is a very well-established measure of finding out what is going on when we're doing a neuronic, like a 10-minute glow, for example. And specifically, you can see with this sort of target diagram that when we move from cognitive evaluation based on behavior that is subjective to a neurophysiological measure, you gain accuracy. Specifically, what we've been able to do with NeuroCatch is actually, and this is really relevant to our conversation today, is gain precision too. So precision, if you extract from science, really means sensitivity. So we can sensitively measure small changes in these brain waves and detect whether or not there's even subtle but significant changes in, let's say, your speed of cognitive processing. So with our current implementation of NeuroCatch, we're really being able to get out in the world and start to detect the sort of treatments and interventions that are actually moving the dial. So just a little science today to give you a bit of background. This is one of our large seminal studies that we did. We've been collaborating in ice hockey concussion with the Mayo Clinic now for over 14 years, quite extensively. And one of the major studies that we published in Brain basically looked at junior A hockey players where we would put them, and I'll explain this radar plot, but the video just allows you to capture quickly that we could get a baseline of a normal looking hexagon. And then in acute concussion, we could see changes in that where you can see that it goes to that triangular pattern. And then we could see that the players returned more or less back to baseline when they were returned to play. So this was one of the first indications that we could actually get to the rink side or a field side or out in the world and measure the impacts of concussion. And this is just pulled from the actual Brain article, and you can see that there's actually been a number of them. There's citations here down below, basically demonstrating that when we took NeuroCatch scans of hockey players at baseline, you can see that the radar plot here is formed from looking at the sensation, both the amplitude and the latency, if we're going around clockwise, and then the attention, again, the amplitude and the latency, and then the cognitive processing, the amplitude and the latency of the peaks. And I'll show you those peaks in a second. But what you can see is a healthy brain vital sign isn't actually, let's say, like blood pressure, a number in the sense of 120/80. It's actually this hexagon shape that shows that these individuals were basically having a normal pattern of cognitive processing before the hockey season started. And when players were basically flagged and diagnosed with a concussion, and that we scanned them in the dressing rooms off the ice, we could see that their brain responses increased in size and delayed in latency in the acute concussive phase. And that caused a shift for this triangular pattern that was highly significant. And at return to play, we could see that they actually did return to play, with the exception of, even though they were clinically cleared with the best that Mayo had at the time, we could detect subclinical changes, impairments still in their basic attention processing, which is the asterisk down in the right-hand corner. To be honest, acute concussion is pretty dramatically clear for us. It causes lots of changes in brainwaves. So we've spent the bulk of our time looking at subconcussive impacts. This would be athletes in hockey, football, MMA, etc., contact sports, mountain biking, where we look at actually their exposure to concussive impacts without necessarily having a diagnosed concussion. And there we can sensitively detect changes in their cognitive and their sensory processing, which you can see on the right-hand side of this slide, and then look at interventions that actually are brain protective to help towards that. This is just moving. I'm going to show you the results from NeuroCatch both in that radar plot format, but also actually in the exact same way you just saw it. On the left is concussion, on the right is subconcussion. This is the actual underlying neurophysiological responses. And this is actually just showing you the same thing. If you look on the left of the response amplitude in red, increasing and delaying for all three of these responses, the N100, P300, and N400. Just to kind of acquaint you, because I want to show you some of these graphs throughout this talk, on the horizontal axis is actually the time of the response in milliseconds. So we measure these responses, we stimulate them with the stimuli I mentioned, and then we measure them in terms of how fast they are in milliseconds, which actually does give their name. So an auditory response for sensory response is a negative going peak around 100 milliseconds. Now, I'll apologize. There's a little scientific convention in this figure because it was a publication that by scientific convention, the negative peaks are plotted up. When you see actually in the positive down, in the NeuroCatch reports, we've actually flipped that. So when I start to show you these responses in the NeuroCatch reports, they will be flipped. But here you can see that one of the key things that we started to zero in on is this on the right-hand side, this cognitive response called the N400. So that's a negative peak typically around 400 milliseconds. And you can see that when we had hockey players who had sensors on their helmets for how much impact they saw, the same with football players. These were youth football players, and we saw put sensors on their helmets, so we knew how much impact they saw. We could see that from the beginning of the season in blue to the end of the season, the response would be delayed in the order of 100 to 150 milliseconds, detecting kind of exposure to contact causing cognitive impairment. And so I want you to sort of see that we can show that concussive injury causes delays in cognitive impairment, and we can track that with brainwaves. And the reason that I'm making that point is because I'm about to show you where things move the other way when we start to look at pre and post neuronic. So just ahead of that, this is just to give you a sense of some test retest and acquaint you with NeuroCatch results. And just for fun, I extracted mine. So these are my NeuroCatch results taken 2 times in radar plot format. So the radar plot here is showing you the 3 responses: auditory sensation, basic attention, and cognitive processing. And again, it's 3 times 2 for size and speed, amplitude and latency. So you see 6 points. And you see them on a green band because the green band is the normative range. So when we scan, we've now scanned thousands and thousands of people, we understand the norm of where it is between sort of 5% and 95% confidence intervals, that this is sort of where people land. The dotted line in this is actually the median. So I'm proud that I traced the median. That would be the equivalent of 120 over 80. So my brain vital signs are sitting more or less around 120 over 80. And what I get to now do is say, okay, my brain is healthy. Now can I track where I get subtle differences? And so if you look between the left and the right, what's catching my attention is definitely I want to speed up my cognitive processing. So on the right side, I'm happy that that is actually moving out towards the edge. When we look at people who have end-stage dementia, they will shrink to the center. So shrinking to the center is basically indicative of cognitive impairment in a severe way. And so if you move towards the outside, you have a faster or a larger response on these responses. And these radar plots, once you get familiar with them and you've seen them enough, they actually give you a quick snapshot of kind of a healthy cognitive profile, and if something's not healthy, where you can go look in particular for the waveforms. Here's the waveform data. Again, what you're seeing on the left is sort of time 1, and the right is time 2. Your eye can naturally see that our brainwaves actually on NeuroCatch operate like a signature. So they will vary slightly, but overall the pattern is very actually repeatable. And you can see here that if you look, again, now what I've done is I've flipped the axis as I promised I would. So time is still on the horizontal axis telling you in milliseconds, but now on the vertical axis, negative is plotted down. And you can see this N1 peak where the algorithm has found it and actually told you how big it is and how fast it is. So my N1 is coming in at about 100 milliseconds, 96 milliseconds, right on where it should be. And then below that is my attentional processing peak, my P300, which is coming in. It tends to on NeuroCatch come a little faster than 300 milliseconds, so it's coming in at 228. And then at the very bottom, you can see after all of this processing, what we really, really care about is kind of the culmination of our cognitive processing. And this N400 peak for me first came in at 452 milliseconds. You can see it's a negative peak between 400 and 500 milliseconds. What's really interesting about this is it does actually delay as we age. So we do see that, younger people have closer and faster than 400 milliseconds. And as we get older, it does tend to sort of move out. If it moves into dementia ranges, that's sort of in the 650 all the way out to 850, 900 milliseconds. So I'm well within my healthy range, but my ego wanted faster. So I was practicing, and then on the right side, you can see if you just look at my N400, I could move that without doing neuronic by about 32 milliseconds. So I'm happy because my fastest is actually 32 milliseconds. Now, for those who are really paying attention, you might also notice that those peaks were not circled, but they're actually captured by ellipses. And what that ellipse measures is actually how variable my brainwave response is. You can think of it almost like HRV for your central nervous system. So when it is an ellipse standing on its end, I often talk about it like a football on its end, that's actually a good sign. because that means the variability in timing is smaller than the variability in the amplitude. So we like to see that. So I'm happy to see the ellipses. And you can see that that actually gives us a measure of how variable our response is, and that will become relevant very soon. So that's just an overview to help you get a little familiar with what we measure when we measure with NeuroCatch and give you a sense of some of the science. There's quite a lot of science that's behind it, but just so that you can get comfortable with the changes we're about to see when we do pre and post neuronic. Fun story. This all really started in 2024 when we were at the Lee Steinberg Super Bowl party, and we've gone, NeuroCatch and Neuronic have partnered on multiple events, and there's such an incredible partnership together. But the Lee Steinberg party was where we started to do pre and post testing for Neuronic. And we actually did it on a college receiver where we would run the NeuroCatch first. Then we did 10 minutes of a glow protocol, and then we did the NeuroCatch after. And that was the first indication that we started to see that the N400 actually moved from 500 milliseconds to 430. So right away, we'd done some earlier stuff. I gave an earlier presentation where we had seen changes in the neurophysiology, but this was one of the most impactful differences where we were like, wow, this is a performance advantage around cognitive anticipation. So why do I say that? When we get the N400, we get it from the words. So for example, if we give you a word pair like bread, butter, your brain actually speeds ahead when it hears bread and loads up that it expects to see butter. So it's actually cognitively reading the pattern ahead to operate on things faster. And when we violate that, we get this N400 response. So if I give you a mismatching word that doesn't belong in the same neighborhood, something like bread donkey, it will actually then cause this N400 because it won't match against the expected delivery. So this is a very, very high level processing skill that's sensitive to things like performance, concussion, and mild cognitive impairment. And 70 milliseconds, as you just saw, the max I moved, mine was 32 milliseconds. So 70 milliseconds caught our attention. So one of the next fun shows that we did was we were together just recently at the Red Bull Tennessee National, basically scanning pro mountain bikers and amateurs as well while they were at the race. And this is really a dramatic example of where I personally started to see some incredible, in terms of photobiomodulation impacts. This was a young rider who had had a crash. His helmet was definitely indicating that it was a bad crash. He was presenting clearly with concussion-based symptoms. And so we did a scan. You can say, in this case, we did 2 scans and we're overlaying them on the radar plot. The first scan was a baseline scan, and you can see there's a dramatic drop in his cognitive processing. So he was presenting clearly concussive, and on the right-hand side, you can see the N400 result was very, very delayed from what you'd expect for a young individual. And then what I wanted to do to confirm that this was actually as delayed as I thought was I actually ran a 10-minute glow sequence and then scanned him again. And immediately you can see that his cognitive processing, when you did the 10-minute glow sequence, his cognitive processing sped up dramatically to 314 milliseconds. And one of the reasons I wanted to show you about this ellipse is it is not a football standing on its end. It is a football lying on its side. So it was still very variable. So by putting photobiomodulation energy in, we could confirm that the response was delayed, but show that it was very unstable in the acute concussion. And that, of course, suggested that he should go get enhanced care. So this was a really nice concussion demonstration of a way to use Neuronic to help with us being able to interpret the scans by showing that his cognitive processing could be improved in that moment, but it was still very unstable and very jittery in terms of its latency and timing. There are so many incredible, intrepid Neuronic and NeuroCatch users out there, and I think we're all incredibly grateful for them. This is from one individual who has done a ton of work basically looking at the clinical implementation in the field. And this is one of the earliest ones for mild cognitive impairment, which was an individual in his 70s 70s and 80s range who was using Neuronic as an intervention around mild cognitive impairment and then measuring NeuroCatch along the way. And you can see that these are 3 scans looking specifically at the N400 response, where in the intake, it was about 486. And then you could see that it was actually improving on the order of 50 milliseconds over the course of sort of post-treatment. And there's a typo in this around mid-treatment. That's actually, they're flipped. So scan 2 was mid-treatment and scan 3 was post-treatment. And you can see that there's an evolution of an improvement in this response in terms of Neuronic having an impact. So this was one of our first indications that it wasn't just necessarily brain injury concussion impacts that we could start to look at using Neuronic, but it was actually also in things like mild cognitive impairment and dementia. This is another example that is really interesting, again, from the same individual, with an individual with mild cognitive impairment, where it's a fun story because up until this point, we had done a 6-minute NeuroCatch scan, then a 10-minute glow, and then another 6-minute NeuroCatch scan. And that was done in this individual as scan 1 and scan 2. But scan 3 was actually a separate 10-minute glow after, where NeuroCatch was done at the same time as the Neuronic 10-minute glow session. So now what is novel is that apparently it's possible to do both a glow session and a NeuroCatch scan simultaneously. And so what we're seeing here is quite interesting because, again, a quick glimpse at the radar plot, you can see that in this instance of mild cognitive impairment, particularly if you look at the sort of the N400 latency, the cognitive processing latency, you see an improvement in the speed of cognitive processing. And I'm showing you on the right-hand side the actual improvement in terms of peaks. And so you can see from scan 1 to scan 2, after 10-minute glow protocol, there's quite a marked improvement in the latency of the N400. And what's intriguing is we weren't even sure that you could do this, that there would be interference from the NeuroCatch from Neuronic running on the NeuroCatch. But then I've actually dug into your technical notes, and it turns out that one part I discovered is that there isn't EMI for the device, as I understand it, and our NeuroCatch seems capable of detecting changes even when the two are running simultaneously. The other interesting thing is back-to-back 10-minute glow sessions don't appear to have necessarily a cumulative impact. You can see that just from the waveforms alone, the lower 2 graphs, that they're roughly about the same, but there's probably not an additional improvement. Let's say from running the second treatment, you're about 356 to 408. So that was quite intriguing. And again, these are all just observation cases. These are not published science and that sort of thing. But what we're seeing is you have the ability with combining these two to start to actually look at the neurophysiological impacts of the sequences that we're running. And then this is actually another interesting case where we have an individual who has moderate to severe, basically dementia, is living with dementia, has like a MoCA of about 6. So very, very much impaired, cognitively impaired. And this is a pre and post Neuronic scan. So they were done with a NeuroCatch, then Neuronic, and then another NeuroCatch. And you can see, I'd mentioned that when you shrink to the inside, that is definitely an indication of cognitive impairment. And so for the scan 1 in blue and the radar plot, if you look at that relative to the median, you can see that there's quite a sort of diminished profile on all 3 responses. And then we went and did the Neuronic, and looking specifically now, you see an improvement and an increase in the amplitude. And actually I'm not showing it, but there was also an improvement in attentional processing. So clinically, this is interesting because we're not seeing latency improvements in the N400. In this case, we're seeing amplitude improvements. So it did provide more activation. The N400's amplitude really dictates how much cortical activation is going on. And it did improve the attentional latency. But in the cases of sort of moderate severe dementia, we can still see differences. We just see that they're slightly different than what we've seen in MCI by contrast. Just some summary to summarize sort of what we're seeing with these early stage changes. The first is that we tend to see consistent neurophysiological pre-post differences following the 10-minute glow sequence. This is something that I can say I've tried to provide you with an example of some of the cases that are the most interesting, but in general, we do see virtually every time we do a pre-post scan, we see changes in the neurophysiology. And then it gets really interesting to try and interpret those changes in terms of the specifics of what responses are changing and what is this individual's situation. It does seem that we can detect performance gains in healthy individuals. That is a little more variable, and I'll explain why I think that might be in a minute. And it is still notably greater than what you would expect even in a shot-to-shot NeuroCatch without Neuronic. So Neuronic has definitely moved to become one of our leading, and photobiomodulation in general, kind of when we're looking at performance improvements, one of our leading quick things that we will be able to do and check. What is emerging, which is interesting, is that I think there are larger effects when an individual is compromised. Particularly when I talk about effects, I mean latency effects. So if you have an individual with MCI or you have an individual in concussion, that's when we tend to see larger potential effects of the neuronic intervention. And I think the acute concussion case in this case was nicely demonstrating that example. With mild cognitive impairment, it's an early trend I tried to show you. It does seem to indicate patient-specific timing gains. They can be variable. It depends, again, when you're dealing with mild cognitive impairment or dementias or cognitive impairment in general, you probably do want to expect that there's going to be variability depending on the specifics of the patient. But we have now some interesting data coming in where you can start to look at actually the difference between if somebody is experiencing or having symptoms of depression versus cognitive impairment. And there's incredible clinical kind of applications out there trying to tease those out by looking at these different technologies. Dementia was a noteworthy example because we didn't see necessarily, again, N of 1, but we didn't see the changes in the timing. We did still see changes in response amplitude, and we saw some interesting changes in the P300, so that was interesting. All of the above that I'm telling you are all in-field observations, so the caveat must apply that none of this has been something we've done in a rigorous research study. And certainly I would say that what we are seeing suggests that rigorous research studies are definitely warranted in terms of next steps. I think really at the time that I'm giving this talk with what we know, both myself and there's some incredible neuronic users. Dr. Colin Daniels is probably one of your top folks that's out there doing some amazing things. And he and I definitely have some interesting questions that we're focusing on, such as like, what is the roll-off effect? I know I've asked, and we're thinking that it might be measured in days. The numbers that I stick in my head is about 36 hours. I'm probably personally going to actually check this myself. I have my own NeuroCatch, and obviously, and I'm going to find out for myself. An actual study to see how long does this effect last would be really interesting to understand it in terms of days and hours. Additionally, I haven't personally done other sequences. I've stuck primarily to the 10-minute glow sequence, but I'd be interested to look at saturation effects. To see if you get one or more, do you see that it is truly saturating like it appears to be? And the other big thing that's always been the case for me about interest with photobiomodulation is its stickiness. In cases where you're compromised, if you have MCI or other cognitive impairments like brain fog, and in our clinic we do use Neuronic for outside of concussion and MCIs and dementias, we use it in things like brain fog. How sticky is that? If somebody recovers, do they stay recovered? And that's an interesting question that we're going to be taking a look at. And then the final, most recent thing, we had a clinical case come through our clinic just recently in rehab from brain injury. And we actually used Neuronic to augment neurostimulation, neuromodulation. This person was on a PONS protocol, which is a neuromodulation translingual stimulation. And to allow for more energetic metabolism with a working clinical hypothesis that might help to take the intervention of the neurostimulation, we started to investigate whether or not photobiomodulation and neuronic were effective in sort of augmenting those as well. I hope that gives you a taste of some of the things we're seeing when we're looking at the neurophysiology before, after, and even during neuronic, and just opens up kind of the ability to objectively show that this is definitely having an impact in terms of cognitive brain function and our brain vital sign measurements.
Yeah, it sure seems to support behavior theory in terms of overlearning in the brain. And that would probably go to the question of sticky, whether how long it takes for something to maintain itself in the brain after treatment. Because I've found that overlearning has to occur. Otherwise, because I did neurofeedback for 25 years, and it has to occur in order for things to stay permanent. But I find the photobiomodulation still needs continuous reinforcement to maintain. That's what I found so far.
Just with itself, like using it repeatedly.
I've been using it for one or the other in neuronic now for a long time. Maintenance of recall.
Very cool. Yeah, yeah. I think for me, I want to look at it sort of in a with respect to clinical treatment versus like a performance optimization, and try and understand, because I'm starting to really see that it has an augmented effect, I think, in when you're dealing with clinical situation. That's where I sense it. So I would sense that, yes, repeated usage is definitely
I
going to
would say particularly in the need for dementia or Alzheimer's. Or, I mean, that's what I think.
Yes, I should have put on one. It was funny. One of my questions that I want to do a head-to-head of light versus the 1070. Thanks to Neuronic, we have the 1070, but I think it would be interesting to see if we see differences between the two.
But it's really terrific.
Yeah. Thanks for your question.
Well, the NeuroCatch is really interesting in the sense that after 10 minutes of glow, that you actually can see a difference either in amplitude or in the other measurement. So I thought that was really quite interesting. I've never seen that before.
Yes, it's what's notable is there are really I'm still looking for a pre-post shot where you're not seeing some sort of changes in the physiology. So we do see, I can absolutely confirm that when you're looking at this, you can expect to see changes in the neurophysiology. The trick is to try and really understand what those changes are telling you.
I don't think you're going to, I think there's always going to be some impact because the brain, that's giving the brain information. And that's basically the brain does something with it no matter what.
Mark, I think I saw your hand go up. Did you have a question?
Yeah, no, I just, Doctor, thank you, Dr. DRC, and I spoke a couple weeks ago, and I spoke to some of his folks here in the States yesterday. I'm a lived experience survivor, but I'm just amazed at the 6 minute scan. And then after the 6 minute scan, Doc, what is the timing prior to results? Yeah.
Thanks, Mark. Immediate. You get the results immediately. So yeah, what happens is when the scan is done, it basically NeuroCatch sends all the data up to our algorithms in the cloud. And if we're being super technical, it's in seconds, because within a minute, it comes back down and is available to be read. And you saw there that if you've got more than one scan, you can actually overlay them and compare the differences in multi-scan mode. So yeah.
Excellent, man. And the last thing I wanted to say, Doc, is that what you did down in Wesley Chapel with the Tampa Bay ice hockey, high performance ice hockey team has been great.
Oh, thank you. Yes. Yeah, we love that project. We've been scanning. I always joke they'll take away my Canadian passport if we don't scan hockey players, but we've expanded now to pretty much every contact sport you can think of.
That's awesome, man. Really good.
Yeah. Anya, I apologize if I just murdered your name.
Hello.
Hi.
Thank you for this presentation. I'm very interested in finding out more about the using Neuronic and the CAP. I'm a survivor of concussion, and I developed a system of as an artist of using exposure to different frequencies of emissive light and wondering, have you worked with artists to see, is it possible to do a study with neuroscientists and follow up with all your data?
I would love a study. As I think we're all aware, research is expensive, so it's always about the sort of the funding for studies. But I think that if I was to leave people with anything, I would say this is such, I agree with you, this is such a ripe area for research. And I think it would be incredible to really put together some research trials. I would particularly start with cognitive impairment. I don't even know if we need to be like exclusive to MCI or dementia or otherwise. Brain fog, like people who are just suggesting or indicating concerns around cognitive impairment and measuring the impacts of a prescription use of neuronic towards that end. I think one of the great things about the ability to, if you do the study with MRI, for example, right, you can't do the monitoring. You have to have people have to come to the hospital. They got to climb in the MRI. It's expensive, whereas you can actually minute to minute monitor for these effects. So I think the ability to put some incredible research, I think, into this equation is so topical. Yes. Thank you for that question.
Yeah, just to follow up, has there been a measurement of the effects on the visual perception? Because some of the problems were in severe convergence insufficiency, loss of depth perception. Does this neuronic measure the perceptual changes?
NeuroCatch doesn't, not visual. It's an auditory input, but I think it would be definitely interesting to take a look at improvements in the visual system, particularly with the light model having coverage all the way down to the sort of cerebellum. I think that's now an interesting area to look at for sure. Yeah, yeah.
Are you aware of the National Institutes of Health, the whole person health, integrative health division, and doing studies through them?
I'm aware of it. Yes, I'm also aware the NIH in general is having challenges with its funding right now.
Yeah, right now it is, right. Dr. Emmeline Edwards, she is the director, and she was
Yeah.
expressing how the funding is being reduced and the loss of true science and validity and repeatability in research, and
Mhm.
also using both female and male in the studies is very important to see
Yes.
the difference. But
Yeah.
I'm very interested in finding out more how to get training and to on the use of this. And please, if you can reach out, I can reach out to you and see
Yeah.
how that could be done.
Yeah. Yeah. Thanks for
Thank
that.
you.
Thank you. Yes. We just published a study in Scientific Reports with, this wasn't a neuronic study, but it was with high school students running the NeuroCatch device, scanning themselves around contact sports. And we published the difference between female and male athletes in concussion. And so in the current regime, if there's any researchers out there, I suppose that's one of the great things I'm enjoying about NeuroCatch. It's not, you actually can continue if it doesn't require large NIH funded research budgets, and it goes
Mhm.
portable, and you get big sample sizes really easy, and you can look at questions like females versus males. I see Dr. Center has a question.
Hey, Ryan, good to see you again. Thanks so much for doing this for us. It's much appreciated. So I do have a question related to the NeuroCatch and what we're doing here. So we're combining mild hyperbaric with photobiomodulation. We actually got somebody in the chamber right now who's using the light device while they're in the mild hyperbaric.
Wow.
We've been using a bit of an antiquated ERP system. We're just wondering if there's a way that we could get our data to you, or maybe that we could start using NeuroCatch, because like I said, we're using a little bit of an antiquated ERP solution to be able to track the effects of our folks that are doing mild hyperbaric, people who are doing photobiomodulation, and then the folks that were using the mild hyperbaric with I guess our testing regime, we're doing about 180 trials on pre-post, and it takes about 45 minutes. But we're also doing 19 channels. You're just using the Vertex, right?
Correct. Yeah. Yeah. That's combining hyperbaric and photobiomodulation is like, absolutely. That would be, so we see pre and post hyperbaric changes. Probably the leading person on that is Tyler Sexton. Dr. Sexton in Florida has done a ton of pre and post hyperbaric changes. But the combination, I absolutely, and I'm always happy to talk to you about NeuroCatch and ERPs, because we run the world record now is 8 minutes and 30 seconds to get a NeuroCatch scan. So the cap can get on like with a minute, 6 minute sequence, and you got the result a minute thereafter, sort of thing. So it's definitely intended to be much more user friendly than existing ERP systems.
And the one thing that we, to Stefania's earlier point, we've started using right eye as a way of doing that vergence, convergence, the problems. A lot of people with the disturbances in the perceptual visual fields. And so right eye tends to look a little bit more at the brain-eye connection than just strictly vision. It's more functional vision. And so that's been super helpful to get that data. We've got about 500 use cases now where we have that data.
Yeah, we partnered with Right Eye on our CAA hockey study in LA with all the folks going into the NHL and those elite leagues, and scanned in a hotel room with Right Eye. Yeah, I love their technology.
Yeah. Well, I'd like to reach out and see if there's something we could do, because I think we could probably do our ERPs better. But
absolutely.
It's great to hear what you've been doing with modulation. That's right up our alley. So thanks again. Appreciate it.
Cool. Thanks for your question, and let me know. I'd love to see the sort of effects of hyperbaric and PBM. That'd be really cool.
We're just getting started, but it's
very cool. Very cool.
There are questions in the chat, Dr. Darcy. Ivana asks where you're located. When did you perform the case study, and any work with people with a stroke, and then any future case studies? And she'd love to be involved with the research.
Sure. Yeah. So we're located in Vancouver, Canada, but we're extensively kind of connected throughout North America. So there's NeuroCatch scanners across the United States and Canada, of course, and actually all the way as far as Australia and New Zealand. So yes, we've done the case studies. Most of the case studies I mentioned are throughout the US, Tennessee, Washington State, etc. So we do NeuroCatch routinely clinically in stroke and stroke rehab. It's used often across most neurologic applications, actually, MS and Parkinson's and what have you. And we're always interested in anyone who's interested to learn more about the applications, for sure. Jacob's asking about the effects of neuronic treatment paired with cognitive processing drills. We haven't done that specifically yet that I could pull up something to show you, but we are starting to combine it in clinic with, we use NeuroTracker a lot for our cognitive training drills. We also use BrainHQ. So yes, that's an interesting thing to see if it's augmentative for that. We're rolling out some performance programs right now, so I'll definitely keep an eye on that. And then Mark is asking about I'm just reading. Oh, it's mostly about Dallas, Texas, and disseminating at ACRM. We were at ACRM, and yes, I think we'd love to disseminate. And you're in Ottawa. Perfect. Okay, we have scanners in Ottawa, a number of very active scanners in Ottawa. Dr. Marcus Besseman would be one in rehab. That would, based on your comments above, I'd connect. Marcus is amazing. Yeah, Collins passed that on. Yeah. Discuss pricing. For sure, I'm the science guy and the academic, but I can tell you the pricing is both a subscription model. So clinics usually tend to do the subscription model, which varies between, I think it's $750 to $1,500 a month. So it is reimbursable. So most clinicians who see more than, let's say, 10 people a month and scan more than 10 people a month can, the pricing is not a barrier, because it actually becomes potentially a reimbursed component for their practice. And then for researchers, they tend to buy a direct, and the sale for it, USD, I think the market price for it right now is $36,000. So that's the cost of it. Most research sites usually have more than one. University of Calgary in their concussion has 10 that they put in a van. So it's not the cost of an expensive MRI. And it's it lasts very long. The other interesting model we're doing is actually also for those who have scanning needs. There's actually the ability to show up and scan. So before you can get NeuroCatch going before you buy one and try it. So you can always reach out to me about that too.
I'm sorry, I missed that. Did you say 36,000?
For direct cost, yes. Yeah. So if you bought it direct, which researchers tend to do, that's the starting price. And then for clinical usage, most people will just do the subscription lease model because it's I can't give you specifics for kind of reimbursement because it varies in ranges and that sort of thing, but the price per scan tends to then become some reimbursable sort of stream for many clinics.
So insurance doesn't cover this.
It does. Third-party payer insurance has covered it. NeuroCatch tends to get embedded in cognitive assessment packages quite regularly. Yes.
Thank you so much, Dr. Darcy. Really appreciate it.
Thank you.
Look forward to all the research that hopefully will come out of this. Very exciting. I appreciate your time. And thank you everyone for joining.